So really quickly, the reason we're having this is to foster and facilitate scientific discussions regarding these two co-located campaigns. And I think there are a lot of research opportunities, observational opportunities, and I want to be frank in these discussions and make sure that we talk about where there are gaps that might need to be filled. Because just patting ourselves on the back is not really one of my goals for this breakout session anyways. I think in a bigger picture sense, we want to advance the greatest possible scientific return from these campaigns and collaborations with the larger community associated with mountainous hydrology that Sail and Splash are seeking to advance scientifically. So here's a quick overview of the schedule. We're going to be talking about these two campaigns so that we're all on the same page with what these actually are, what Sail and Splash are. Then we're going to talk about hear from Rob, Cifelli, and Chandra about precipitation observations and science opportunities. We're going to hear from the aerosol process subgroup within SAIL about aerosol observations and science opportunities there. We're going to hear a number of different presentations on surface flux measurements and the science opportunities there, and then hear about the integrated aspect of SAIL and its connections, SAIL and Splash and their connections to surface and subsurface research and the achievement or the efforts to stand up atmospheric through bedrock science opportunities. Finally, we're going to hear about connections to a new opportunity called AI for system processes, or AI for ESP. But really, this is about discussion, and I'm just trying to see the discussion here with some ideas regarding modeling activities, data integration, outreach, and second-year hypothesis development and testing. But that's really just to sort of get the conversation started. We'd like to really hear from you, and really don't want to have a heavy hand in the discussion. As I mentioned, we're recording this session. Please feel free to ask questions in the chat, and then we'll open this up for discussions moving forward. Just to sort of ice break a little bit within Zoom as much as we can. If you are interested, we'd certainly be open to have you post your name, your affiliation, and really what brings you to this meeting. If just a few words about why you're here, so that if there are some potential opportunities, we can for connections, we can move those forward. I also wanted to point out that we have a Slack channel. So Scott is I think is much more familiar with that than I am. I'm still a newbie, but I'm learning, especially through the poster sessions and earlier through this meeting. With that, I wanted to ask if there are any questions, and then I'll just start it up. Okay, not hearing anything. All right. Okay, real quick. We're here with SAIL because of SAIL and Splash because of the really importance of water resources to humanity, but also the importance of mountains for developing and delivering these water resources. There are a wide range of complex atmospheric and land atmosphere and surface and subsurface processes at play in complex terrain, and which are shown in a cartoon fashion here. And when we kind of zoom in on some of the different major watersheds around the Earth, we see that the Colorado River is really a significant one. It's the most hydrologically significant watershed in mountain range in North America, and has a huge impact on the Western United States and beyond. Unfortunately, this river its discharge is decreasing quite substantially. A recent paper showed that it was decreasing about 10% per degree Kelvin of warming since 1920. So, and this shows the decrease in snow water equivalent at a number of different stations around the Western U.S. And so it's a bit of a tough place to be for water resources moving forward, and we'd like to advance the scientific understanding of how those are going to how those are produced now and how they might change in the future. Our system models are a potential tool for this. A recent paper showed that the details of how you actually stand up our system models within complex terrain really do matter. And so if you use a variable resolution projection of water resources in mid-century versus a statistical downscaling solution, as shown one to the second to the left, regionally refined models versus the raw climate models, we see very different projections of change in water resources moving forward, and a lot of that has to do with the resolution of processes within complex terrain. And so, so complex terrain presents a stressing case for models, and there's a need to focus on the details of atmosphere and land atmosphere interaction processes. The Mountain West, unfortunately, there's a sparse network of weather stations that capture these processes across scales, and this cartoon shows the range of interactions that a handful of stations are meant to capture, and this puts us in a place where we're really under observing a wide range of processes that we'll hear about moving forward, and to the extent that sometimes modeling frameworks can surpass observational products, as shown in a recent paper here. So this has motivated the deployment of a second armable facility, SAIL, to the East River watershed, and we're really with SAILs looking to address uncertainties in atmospheric interactions with watersheds because they complicate mountainous hydrology research substantially. And this campaign is going to be co-located with a longstanding DOE research project, the Watershed Function SFA, which we'll hear about more, that does surface and subsurface research. The campaign will deploy near Crested Butte, Colorado from September 2021 to June of 2023. This shows on the left the is the Colorado River watershed, which is 640,000 square kilometers. We're zooming in on a 300 square kilometer area, the East River watershed. This area has an elevation range. It's pretty high altitude, between 2,500 and 3,500 meters above sea level, and it receives 500 to 1,000 centimeters of snowfall per year, and it's pretty cold in the winter time and pretty pleasant in the summer. The watershed is somewhat shaped like a bowl, and on the south there's Crested Butte Mountain that sticks up prominently, and then there's the valley here, and the East River Valley, and then a number of different mountains surrounding that valley to the west and east. And there's a significant amount of heterogeneity in, for example, the snow depth and presumably precipitation. The and the reason I say presumably is because, again, we're under observing these processes currently, but we can see from snow depth that there's snow depth observations from the Airborne Snow Observatory, a wide range of snow depth across this area, almost double the amount of snow at the Schofield Pass Snowtell Station, which is about 15 kilometers to the north of the Butte Snowtell Station, even though they're at about the same elevation. And this area is quite hydrologically significant. There's a number of different streams here that are kind of shown pictorially, and the terrain is quite complex. And I've shown here the location of the SAIL AMF2 and the radar and aerosol observing system, so we'll have two locations, one in the center of the East River watershed and the other on Crested Butte Mountain. The SAIL involves the deployment of the AMF2, as I mentioned, and this will be going to Gothic, which is, as I said, in the center of the East River watershed. It's a really exciting time. Installation is happening as we speak, and this is a very recent photo of where the containers are going to be placed, and we're going to be measuring radiation, temperature, humidity, winds, precipitation, and clouds from this location. And then we're also going to be measuring about just under 8 kilometers away, where we're going to have the Aerosol Observing system and an X-band precipitation radar. The X-band precipitation radar, as I mentioned, is going to be at this elevated location. You can see here a drone picture of the area in wintertime, and we've done some beam blockage analysis that shows that in wintertime in the center, we're going to have nearly 20 kilometers of range to be able to make precipitation measurements. And during the summer, where the precipitation is a little bit more higher, we'll be able to have a wider, larger sensitivity, larger domain. We might have a tethered balloon system, and we're doing some test flights there. So stay tuned to hear a little bit more about that once those test flights are complete. And we're excited to stand up collaborative resources with the Watershed Function SFA, which we'll hear about more from Ken Williams, and really to advance cross-disciplinary research, which is a lot easier said than done. And we're really looking to really advance that substantively through direct connections between observations, as shown on the right here, where we'll have SAIL and watershed function measurements, and then modeling capabilities at the same time to connect those and advance modeling. The team, the core team spans 4 national laboratories, 10 universities, and 2 research centers. But there's a much larger extended community, and we're looking to the ARM and ASR community to really to participate and provide perspectives and hopefully advance the science here. There are a number of science objectives. Briefly, we are looking at the precipitation and why we're seeing the variability in it, and many of the processes associated with that. Looking at snow processes that are affected by winds, specifically sublimation and redistribution, a number of different aerosol processes that impact radiation and precipitation in varying ways, and then the land-atmosphere interface and really what's controlling the energy and mass balances at the surface. I probably went a little long here, but if you please just go to sail.lbl.gov. You can also visit the poster here. We have a bi-weekly teleconference, so please join that. And I want to point out that we're really looking to nucleate, pun intended, the research activities, and we're really excited to hear about one of those activities, the NOAA Splash campaign, which we'll hear about now from Gijs. So, Gijs, should I share my share your slides now?
Yeah, that would be great, Dan. And in the meantime, I will do a quick preemptive apology. I'm on vacation and I've got trucks and mopeds and Harleys and the occasional ferry horn going on behind me. So hopefully that's not too distracting. So Dan mentioned SPLASH, and SPLASH is a study for precipitation, the lower atmosphere surface for hydrometeorology. It is a NOAA effort that a bunch of us have started to develop, and you can see a lot of the names here on the screen, people spanning multiple NOAA laboratories, universities, private sector. And I'll talk a little bit more about all of the different pieces of SPLASH in a minute. Next slide, please. So in terms of splash science, Dan did a really nice job of giving some background on the general science themes, and a lot of those hold true to splash. I think splash in particular, given that it's a NOAA effort, is focused on kind of the shorter timescales, weather, and maybe up to seasonal type of timescales. And so some of the different categories of scientific topics that we're most interested in providing information on include clouds and precipitation for precipitation forecasting, understanding snow level, et cetera, precipitation microphysics, surface properties, so thinking about snow cover, surface albedo, soil moisture, and how those all influence the prediction of weather and water in the area. Of course, mountain weather, thinking about performance of the newer meteorological prediction systems that NOAA is assembling, like Rufus, and how they're performing at high elevation and in complex terrain, and then all of those pieces connecting back to improved prediction at a variety of timescales, connected to different modeling tools like the high-res modeling feature programs that NOAA has and the National Water Model. All right, next slide, please. So to do this, we are adding to a lot of the infrastructure that's in place. Dan mentioned that there is an existing network of observations. You see that in the symbols here. If you can click just twice more, Dan, that would be good. That'll add both the DOE assets as well as what NOAA is bringing to the table. So all the blue pieces here are things that NOAA is going to contribute as part of SPLASH, and that includes a variety of different radar systems. So a second X-band radar, a couple of snow level radars, surface flex stations, a variety of surface flex stations, the clamps trailer for part of the year, surface precipitation gauges, distrometers, and another set of remote sensors for lower atmospheric profiling. We're also working on bringing UAS to the region to make measurements of both the surface and lower atmosphere. And I will say SPLASH is set up to be a one-year project starting this fall and extending into next summer. Next slide, please. So looking at some of the sites, you can see the map on the lower right of the valley area. I've indicated where each of these sites is. One of the goals that we had for SPLASH was to extend the spatial reach of the observations that were in place and provide more detail along the length of the valley. And so Avery Picnic was an attempt at doing that. Here we'll be deploying some of the atmospheric surface flex stations that were deployed from Mosaic. And one of those will be going to Avery Picnic site, which is a remote site north of Gothic, where there really is very little infrastructure, but is a kind of critical up valley measurement. Next slide, please. Kettle Ponds is the next site that's just south of Gothic, and that's going to be one of our super sites where we have snow level radar and distrometer set up. We'll have full surface energy budget measurements, including radiation, turbulent fluxes, and soil moisture. We'll also plan to use Kettle Ponds as a primary UAS observing site. Next site. The Brush Creek site is south of Mount Crested Butte. This is another place where we'll have a fairly heavily instrumented location, including another snow level radar and distrometer, another set of surface energy budget measurements. The clamps trailer I mentioned, that's fall, but that includes both ARRI type system and microwave radiometer, as well as Doppler LiDAR system. and is another site for potentially UAS operations. Next one, Dan. And finally, the Roaring Judy site, which is at the far southern end of our domain. This will include the second X-band system, which is positioned nicely because it provides coverage on the other side of Mount Crested Butte, and also has an eye on the Taylor Reservoir off to the east. We're also working to deploy there an assist system, so ARI type of system, and another microwave radiometer for boundary layer profiling in the fall to around New Year's, and some surface met instrumentation. Next slide. In addition to those systems, we also have now time on one of the NOAA aircraft to conduct snow survey flights. The No Risk team is an operational snow survey team that predominantly actually focus on the Midwest, but they have done mountain flights in the past, and they can provide snow water equivalent lines. So thinking about 10-kilometer scale integrated values, and they'll be sampling around the area, hopefully at a variety of different levels through the valley floor up to the peaks. And they will conduct a series of flights in March, as well as a series of flights in May, to look at both peak snow and the end of the melt season to see what's left at that point. Next slide. We're really excited about outreach. I think we've got a lot of great assets going in, and have a good opportunity to connect to both the local community and the broader community on the importance of this region for water in the West. I think there's already a lot of news I've read, in the last few weeks, a lot of stories about the Colorado River and its importance. And I think we can build on that with a lot of the activities that we're planning to undertake here. So just in terms of status, status is good. We've got a lot of partners and a lot of stuff that's going to be installed this fall. We're always in search of additional enthusiastic contributors and collaborators. From NOAA, we're working to connect with Weather Service, including the River Forecast Office and the Weather Forecast Office, the ASRE program, which is the Atmospheric Science for Renewable Energy program, to think about how mountain flows could be leveraged for mountain meteorology, can be evaluated for renewable energy projects. And of course, connecting with DOE and SAIL, and we're looking for additional stakeholders for these observations. And funding is more or less in place at this point. I mentioned the UAS part. We're slowly connecting the dots there, but we're moving forward. And I will move on here so that we have more time for discussion, Dan.
All right, thanks, Gijs. Okay, so I now will hear from Chandra and Rob about precipitation observations and processes. Chandra, do you want to share your screen?
Okay, hang on a second. And can you hear me?
Can hear you just fine.
Can you see my screen?
We can.
I am going to go to full screen and let Rob do the audio, and I will be the PowerPoint operator.
Perfect. And that looks great, Chandra. You're good to go.
I am good for something. Rob?
Yeah, so can everybody hear me okay?
We can.
Okay, good. This is took me 35 minutes to log in with 3 different computers. So third one was a charm. Yeah, Gijs and Dan, thanks for the good overview. We're gonna, Chandra and I are just gonna say a few things about build on the X-band radar measurements that we intend to collect for splash and sail. So we're just going to do a very short version of a talk we gave a week or 2 ago at a splash sail meeting. So go ahead, next slide, Chandra. Okay, so I showed this, but I really like this slide because it emphasizes the different pieces that are being addressed not only in the splash program, but by the radar in particular. And there are 4 categories that Gijs covered: the precip, the surface, the whole weather phenomenon, the mountains, and then improving predictions. So I'm circling, Chandra's showing where the radars are really going to contribute, we think. not only QPE, but microphysics, convective initiation for summertime monsoon events. Keep going, Chandra. The orographic precip. And then the improving prediction part is really important here. National Water Model, and then Gijs also mentioned RUFUS, the Rapid Refresh Forecast System, what the HER is transitioning into as part of NOAA's Unified Forecast System development. Okay, next slide. And gap filling radars, thanks. Okay, so we're not going to go through all of these. Just going to say quickly a couple of things about the processes, some of the major questions we're hoping to tackle here in the East River in terms of what processes are contributing to precip. So this little cartoon sort of illustrates broadly, things ranging from cedar feeder to orographic flows and lee waves. Next slide. And then how much precipitation is falling. In the bottom here is just an example of what we're using in the San Francisco Bay Area for liquid precipitation in orographic precip. So on the left, just showing a combination of polarimetric variables, specific differential phase, and horizontal radar reflectivity. And in the right, just showing an example where the gauges and this product that we've developed is doing a good job. But next slide. As we all know, solid precip is way, way harder, mostly because of the variable density. So that's where the distrometer data that we're collecting becomes really important. And we'll be using that to retrieve density. And for the broad QPE approach from the radar, we'll be trying to make use of polarimetric information, again, specific information, specific differential phase and horizontal reflectivity. We'll work out those relationships. And the plot on the lower right is just a demonstration from one of many studies showing that using multiple parameters can improve the retrieval quite a bit. So in the red is an example of differential phase and radar reflectivity. So next slide. And these are some of the ancillary measurements that are really important for the QPE. I mentioned the distrometer, which I didn't spell correctly down there in the lower left, but also the snow level radars. We'll have two of those. Sorry. Let's see, so the snow level radars and then precip gauges, there'll be a number of those. And in the right is just an example of a display, a time height cross section from snow level radar in the upper right, and down on the 1, 2, 3, 4th panel, showing tipping bucket and Parseval distrometer rainfall. And this is drop size distribution information, just to show that all these ancillary measurements are really important to bring together here. Next slide.
Hey, Rob, can I add the modification we are making for the snow level radars?
Oh, please. Sorry, Chandra, go ahead.
So we are making a major upgrade to the snow level radar, adding a second channel with the cross polars, with the second polarization. And I'm working with NOAA to make the mod. And then there's this new technology that will be tested here before we go to the field. And it's just going to open our eyes in terms of crystal habit determination at the snow level radar location. So this is getting a big upgrade in terms of technology and measurements. Next slide.
Yeah, and this is a slide similar to what Gijs showed, that the circles show the location of the two X-band radars. So there's one at Mount Crested Butte for sail, and then the splash one is adding the radar at Roaring Judy. And this just shows the terrain that we're challenged with here. So as Gijs mentioned, Roaring Judy has a better, more broad view, but we still have blockage here to deal with. So Chandra, I think I'm going to pass it to you now.
Okay, so we are doing really clever and interesting things for radar deployment, because it's been well known that we are going to places where nobody has gone before, which is really deploying radars in deep mountain valleys. I've been wanting to deploy a radar in Estes Valley here for a long time, but I had to travel a little bit more south to get this done. This is the terrain picture of where the sail radar will be. There's a lot of details that shows background on how much analysis has gone in before we picked a site. And RMBL, that's like the local slang name is Rumble, is where all the AMF2 observations are. So these X-band will look over them. So you have a double look, a horizontal look, and a vertical look, which is a very unique set of measurements and that very high resolution because it's only 8 kilometers at 1 degree beam. So we will be looking over that in a vertical profile. And here is the nice view that you can see. We are looking right through the valley, and it's very rare we will get such a look through the valley. That is, we look at precipitation deep into the valley, which you cannot see from satellites or which you cannot see from this big long distance radars that are deployed everywhere. And here's a line plot along the line. This red line is where the rumble is. So it's almost looking horizontally and everything up from there. And you can see that different elevation angles, how it's going to look. And then we're going to get really precise measurements of precipitation of everything that Rumble is seeing with the AMF2. So you will get a adjoining picture how things look. So here is a concept diagram of bottom line when a lot of people talk about snow being blown over the top of the hill. And this concept was written into National Academy Studies about I think 15 years ago, how you have to really deploy equipment on both sides of the hill, the mountain ranges, to really get observations, because these are observations that are hard to observe. So simultaneously, you will be seeing this from 2 radars. This left side is a splash radar, right side is sail radar. Suddenly the whole setup went on steroids, and then if you do coplanar scans, you get multiple Doppler. So you really see the wind patterns going through. So here are some boring, nerdy pictures about coverage and so on. So I'm going to skip through these in the interest of time. Essentially, you see this type of coverage. This to the left, it's coming from the splash radar. This is from the sail radar. And you can see the gap that is being hit by sail radar is being filled by splash radar. So it is combined lifting up of everything. So here's some details. That is, the red is, in this case, I've changed the color code. Green is rumble. Red is sail radar location, and then it's sitting on this side of the mountain. And then it's 15 degrees is the lowest elevation you can see, and then you can scan over. And then from the splash radar, you can look over all these regions a lot. So you can do multiple Doppler at much higher locations. That's the last slide. Thank you.
And thanks, Chandra and Ra. That's really fantastic presentations. Again, if you have any questions, please post them in the chat, and we'll get to those during the discussion. So I think in the interest of time, let's move on to hear about aerosol processes. So Allison, please, would you be able to share your screen now?
All right. Can everyone see my screen? It should be in slide presentation mode now.
Yep.
Looks good.
Looks good.
Okay, thanks. Just needed to hear one person. All right. Thank you, Dan, for inviting me to speak about the aerosol processes. And on behalf of the sub-team. I'm going to be giving just a brief summary of some of our science goals and objectives, as well as our measurements plans and those updates, and invite discussion for more interest from everybody here. So thank you for participating. So in terms of the aerosol regimes, we are very interested in their impacts to both the clouds and also to the radiative impacts as well. So we know we expect to see different kinds of aerosols transported to the region and different life cycle processes within this high mountainous terrain that is a very unique opportunity for us to look into within the SAIL campaign. So without much ado, in terms of the processes and regimes, we know that we have different kinds of aerosols transported to the region, and then also different life cycle events, formation, growth, and removal that are going on within the area as well. You can see over on the right, there are seasonal cycles. We also, of course, would expect there to be diurnal cycles of the aerosols as well. But largely, the radiative impacts and impacts of aerosols to both the surface and then also the cloud interactions have been poorly constrained by observations, and so SAIL is looking to meet that gap. In terms of the deposition to the surface, the absorbing aerosols have a very large impact within the area. You can see just from a picture, an image of a dust on snow event. Some of these dust events are local, some are long-range transport. We're looking forward to learning more about these different dust sources and which ones are deposited onto the surface versus which ones remain in the atmosphere. This has been an interesting topic area from within DOE, going back to the Absorbing Aerosols Workshop report back in 2016. And so in addition to the dust events, we know that there's also black carbon and also brown carbon, which has also been implicated in these kinds of surface interactions in high mountainous terrain, but has been largely understudied. One of the unique things that we have going for the SAIL campaign is some snow pit, coordination of snow pit observations and sampling that will be done by Mackenzie Skiles's group, one of the aerosol process co-PIs on the campaign. She'll be coordinating measurements of snow pit albedo, depth and density and temperature profiles, in addition to looking at the black carbon that's deposited into the snow by looking at offline dust and black carbon measurements back in the lab. And so we also are interested in coordinating our aerosol measurements with the radars and these other kinds of observations of radiation from the surface. And this is just a slide showing you some of those images, as well as the modeling kinds of efforts that we can do in coordination with the say soot or dust on snow events, and how those are impacting the water hydrology within the region. We also are interested in the aerosol life cycle events, and so these are the different chemical reactions going on in the area that we expect that we should be able to observe both new particle formation and growth events. There also are likely to be transported events and intrusions from the troposphere when you have mixing of pollution that's transported, and then free troposphere aerosol as well. That could be interesting. Some of the other things that could be going on are the formation of brown carbon from secondary organic aerosol sources. And as I mentioned, we want to understand more about these aerosol processes and the chemistry that contributes to them within the area. Some of the newer measurements within ARM campaigns are the ice nucleating particle samplers. And those are led by Jesse Creamian and Tom Hill at CSU. And these should be able to tell us more about the INP sources within the area. And this is included within the Aerosol Observing system as one of the newest aerosol measurements. So we will be relying heavily on the Aerosol Observing system measurements, as they will be there for the full deployment. Actually, I believe there'll be a little delay in the start timeline, but in any case, we're very excited about the additional measurements that we had added to the standard AMF2 deployment, which are the time of flight aerosol chemical speciation monitor, as well as the single particle soot photometer, which will both be there for the full duration of the deployment, in addition to the cloud formation measurements, optical properties, trace gases, and physical properties that also one of the, in the physical properties, some of the, we actually will have, I believe it's an OPC instead of the APS, so my apologies on that one, but we will have a larger size distribution characterized for sale, which is also very helpful for these dust events. In terms of an update, as I mentioned, the Aerosol Observing system is actually, we spent a lot of time and effort looking into where would be the best place to locate it. And so as you saw earlier on Gijs's map, and also here, the AMF2 will be located in the town of Gothic, nearby the Rocky Mountain Biological Laboratory and also the EPA CastNet site. The Aerosol Observing system is going to be located on the Crested Butte Mountain. We selected this location in order to be able to measure some of those intrusions from the free troposphere, as well as to get away from some of the local sources that would be likely to impact us within the valley. We also have plans for tethered balloon system measurements that should include the aerosol configuration. So we will have number concentration and size distributions, although those are still TBD, as Dan mentioned. Some other, we were hoping to discuss more projects, as we know that there have been SAIL-related aerosol projects submitted, but stay tuned for those announcements. And also guest instrument deployments have been submitted to ARM as well. We are happy to announce that we have one undergraduate research project already started, and that will be looking at black carbon and soot, and that's with Jennifer Herdman at Western Colorado University. And we are welcoming new and additional projects. And so to continue that, we did a survey of the Aerosol Processes working group to gather interest in aerosol-related intensive operational periods and additional guest instrumentation deployments. There seems to be a large interest, and so please reach out to us or discuss here. There's definitely time. This is a longer deployment, and so even if you're only able to deploy, say, in the second spring, we welcome your measurements. We also welcome discussion in the latter part of this breakout about if there are additional observational measurements needed to meet our science goals of aerosol processes and interactions with clouds and radiative processes on the surface, specifically related to modeling efforts, and then also keeping in mind both the warm and cold season processes. We are looking to coordinate with the NOAA Splash campaign as well. We're very excited about that project being funded. And so without further ado, thank you everyone for your participation, and we look forward to the discussion. Please don't hesitate to reach out to any one of us on the Aerosol Processes co-investigator team if you have any questions or would like to work with us. Thank you.
Great. Thanks, Allison. I really appreciate it. So in the interest of time, I'd like to move on. We can hear about surface flux measurements, and this is kind of a tag team effort between the DOE side and the NOAA side. I guess so to pass the baton, maybe we could hear from Tilden first on the NOAA side of the surface flux measurements that that Splash is standing up.
Okay. Let's see entire screen.
We can see your screen. And
Is that good?
That looks great.
Okay.
Speed.
All right, so I'll try to make this brief. Gijs and Rob did a great job, and Chandra discussing some of the systems that are going to be deployed during the splash or our component for the next year. And in particular, we're going to have several service energy balance systems, and I think that'll be somewhat of a challenge, and I want to spend a little bit more time talking about sort of the more specifics of some of those measurements. For us, we're going to have 2 tower systems from ARL. One's going to be at Kettle Ponds, the other one's going to be down at Brush Creek. We are going to deploy using the RM Young 81,000 VRE and an open path ERGA, sampling at 10 hertz, either 30 or 60 minute averages. And these are standard outputs that we generally produce from the heat fluxes, CO2, friction velocity, and then the turbulent components. And then we can derive from that, I think, some roughness lengths. And then we are, in addition to the GML group that's going to be doing a more detailed with direct and diffuse radiation components, we're also going to be just adding in our 4-component net radiometer. That'll provide some redundancy. So we'll have some data for comparisons, which will be nice to be able to do. We also are going to be having 3 sensors on top of the tower that are going to be looking down and measuring surface or skin temperature. Because we think that might be important when it comes to looking at some of the flux data. For soils, we're going to be using our own probe, which has sensors that go down to actually a meter. But for soil moisture, it's going to be the new CSI Soil View. And this goes down to, we think, 50 centimeters with the appropriate sampling of every 10 seconds. And we're going to be averaging outputs to 1 minute that we can aggregate that 30-minute data. But I think having that higher resolution data might be useful for looking at some of the critical heat transfer and effects that on radiation on the short-term basis. And then we're going to be deriving things like the soil heat flux and the soil heat storage. And the reason I think that's going to be an important quantity here, so this is actually a graph from Illinois in the springtime, which shows the total heat flux, which is the top graph, from 3 separate temperature profiles. And the takeaway message here is that when you combine the ground heat flux, which is the center graph, with the storage term, you're looking at upwards of over 200 to 250 watts per square meter. And that's a sizable component of the energy budget. And I think it'll be important if we look at that, especially in the terrain that has fairly low LAI in the early part of the season. These are very cold soils, that these fluxes are going to be quite large. So I think it'd be really wise to think about having some redundancy when it comes to measuring the fluxes, whatever technique you prefer, and to have some good profiles of soil temperature, at least down to a half a meter. Right, I'll get off that soapbox. Other standard measurements, of course, will be temperature and precipitation and humidity and barometric pressure. We'd like to get things like soil leaf area index, soil thermal conductivity. I'm going to be doing some measurements of that and potentially getting some hyperspectral data. We are going to be deploying tower cameras that'll provide hourly data or hourly snapshots of what the conditions are like there. And some of the things that I'm going to be personally focusing on with regard to the ecovariance, and the reason that we're having flux measurements at 2.5 and 10 meters is to be able to ascertain vertical flux divergence, because we think this is a really challenging environment for flux systems. So we want to know how often and in what directions are we really in these situations where we could be having active advective conditions. And we also are going to be looking at and having profiles of temperature and wind speed to sort of see how well or poorly our flat Earth flux profile relationships actually work in complex terrain, or whether they work at all. So anyway, with that, I'm going to pass it on because I think I used up my 5 minutes.
Thanks, Tilden. Yeah, so I was hoping we could hear a few words from Dave Duchess now. He's been doing some measurements in the area and of fluxes already, to get his perspectives on SAIL and the larger sort of measurement networks that are being considered.
Okay, thanks, Dan. Can you hear me?
Yep.
Yeah. Yeah, I wasn't aware you're going to put me on the spot, so I don't have a presentation to be made here. But let me just go ahead and build on a couple of things that Tilden said, because I think he raised some really good issues for these different sites. As some folks know who've been looking at eddy covariance land surface flux measurements in this particular area, we've had a small flux tower working in the riparian zone of the East River since about 2017. And it's an interesting distinction from what Tilden presented in the sense that we are down in the riparian area where the soils stay mostly saturated, if not fully saturated with inundated surfaces for a good chunk of the warm season. So the issues that Tilden related to the radiation transfer, and particularly the ground heat flux, and the importance of looking at the amount of transfer that's going into the ground, particularly when snow and water are there, have been a big issue. And we do see some of those the signatures of those behaviors moving forward. Having a short tower over riparian vegetation, we were looking at a fairly small footprint of that riparian corridor where there's largely grass and shrubs and a bit of the river in the footprint mosaic. And so I think what will be interesting is we see some of these other flux measurements deployed is to get a sampling of the diversity that's occurring across this basin. The Kettle Pond site is a topographic bench, which is sort of well above the riparian zone, and certainly gets wet during the melt season, but also dries out very quickly with sort of a western southwestern exposure. So the dynamic range there is going to be quite interesting to contrast with what's been going on in the riparian area. Beyond that, as also noted, there's just a lot of difficulty. Apologies for the background phone there. A lot of difficulty in characterizing a lot of the other dominant communities in this area, which include a lot of the forest canopies and then some of the alpine, subalpine areas because of the extreme topographic relief. There is a proposal pending with DOE right now to install some additional flux measurements over a large, fairly homogeneous aspen stand, as well as a large coniferous stand just to the east of the East River Basin, basically over on the Slate River side. This is all within the Upper Gunnison. We're talking about maybe a straight line distance of 15 to 20 miles away. So pending that, we might get some more sampling of some of these other forest communities to add to this mosaic of riparian and now this sort of more grassland area that Tilden's got. So hopefully we'll see what happens. And again, just can't emphasize enough, these are unique measurements going in challenging areas. We certainly expect to see some interesting behaviors come out of this. Hope that helps, Dan.
Yeah, great. Yeah, thanks, Dave. I appreciate it, and we're looking forward to to the confluence of splash observations and the two light cores associated with SAIL, and appreciate the perspectives that have been built up of the area, especially with those riparian zone measurements, and trying to really get end sample end members as much as possible.
Dan, sorry, can I jump in for 1 second? I noticed that Matt is also on the phone. I wonder if he would be willing to say a couple words about the ASFS system, since people may not have been familiar with those from Mosaic. Matt, are you able or willing to do that?
Wow. All right. I'm prepared as well. Dan, is that something you'd want to hear?
Oh, sure. Yes, absolutely. Thanks, Gijs, for pointing this out. This is an important measurement.
Okay, well, I'll keep my camera off for the sake of not being prepared for being on camera. But yeah, we have a couple Flux stations. These were built and deployed at Mosaic for measuring all terms in the surface energy transfer. So radiation, turbulent heat fluxes. We'll have some subsurface for looking at storage and kind of subsurface conductive heat flux. And Gijs mentioned in his presentation that we'll have one kind of up valley from Rumble at the Avery picnic site, and then another in the kind of super site that's down valley, not too far from one of Tilden sites, to look at a little bit of spatial variability there. And these stations are, we'll call them semi-autonomous. They have a little fuel cell that provides the power, so they don't need to be by any line power. So that's, I would say, their strength in this this situation, because they can be in these more difficult to access locations to provide some of the, importantly, the spatial variability. You know, this is one of the big questions I have is, you know, we go out there and we make great measurements at point locations. And as we've heard in all these presentations, this is a very complex terrain. And so what do those point measurements actually mean? And I think this is one of the great values that we bring with having all these different stations deployed at different locations across the valley to try to understand how to upscale and aggregate the information we have on things like energy transfer at the surface. And so that's one of the things we're trying to address with these measurements. Otherwise, that's all I've got. Thanks.
Thanks, Matt, and thanks, Gijs, again. So I think we will now turn to hearing from Ken Williams about connections between sail and splash and the ongoing surface and subsurface research projects, modeling and measurements that are going on in the East River watershed and beyond. So, Ken.
Super. Thanks, Dan, and apologies in advance for the occasional dropout, dealing with somewhat of an unstable internet connection here. Is the fact that sail and splash are not coming into, if you will, an empty vessel. They're coming into a fairly intensively studied watershed from the perspective of looking at processes from the top of the vegetative canopy, whether that's grasses and shrubs or riparian vegetation, as evidenced in this particular photo, to forested canopies, all the way down to the bedrock. And that's work that's been ongoing here in the Upper Gunnison since mid-2014, when I sort of migrated a large Office of Science funded so-called scientific focus area, an SFA, from a long-term field study site in Rifle, Colorado, to this field study site that you've been hearing about today that we refer to collectively as the East River Watershed. And so our scientific focus areas, referred to as the Watershed Function SFA, really has some fantastic opportunities looking forward over the next 2 years to have synergistic relationships with both sail and splash to really extend this sort of vertical continuum of process understanding in mountainous systems from bedrock all the way up to the boundary layer. So super exciting. So I wanted to take the opportunity then to introduce you to the Watershed Function SFA, which really has as an overarching question is this: how do mountainous watersheds retain and release water, nutrients, carbon, and metals? The metal side will become a little bit more evident as we go forward. And really specifically, what are the consequences of early snowmelt and drought on water availability and biogeochemical cycling at episodic to decadal timescales? And so our objective with this approach is to subdivide a very, very complex watershed system into a collection of really representative or constitutive elements, what we refer to as subsystems, that we can actually intensively characterize, monitor, and then ultimately model as an integrated system. And so the outline for today is I'm going to introduce you to our specific research components. Let me give you an overview of what I refer to as a community watershed, of which sail and splash and our other participants today will be brought into this community. Look at some of the research infrastructure and community data sets that will be broadly applicable to sail and splash. And I'll leave us with some, certainly not a prescriptive list, but a tentative list of potential research questions that can only be addressed by this coupling of the watershed function SFA with both sail and splash. So the SFA research components, again, we're trying to subdivide this very diverse watershed system into components that we can sort of tractably characterize and monitor and model and understand. So the first component really looks at what we call the eco-hydrogeology component that seeks to quantify and predict hill slope contributions to river chemistry. So really understanding how these water, nutrients, carbon, and metals find their way from vegetated hill slopes through soils, groundwater systems, and ultimately discharge and export by inland waterways, specifically rivers such as the main stem East River. Within that context, we have another component focused specifically on river corridor processes, which is really understanding how hydrobiogeochemical exchanges between surface water and groundwater along the river continuum alter chemical exports as that water flows progressively further and further downstream. Lastly, we utilize an aggregation component, which we refer to as watershed aggregation, that really starts to try and stitch together those hill slope to groundwater to surface water components into an aggregated whole that allows us then to really sort of pull that jigsaw puzzle together and really link all of those component behaviors, those system component behaviors into, as I say, an assembled whole, primarily through a couple data modeling effort. So give you a brief overview then of what we refer to as the community watershed. Dan touched on this earlier. What we're looking at here is a representative headwater system in the upper Colorado River Basin. While we're working in the East River watershed and the upper Gunnison more broadly, we're not studying this system purely for the sake of understanding processes within the East River. We really want our approaches here to be site agnostic. We're really interested in trying to have an intensively studied field system that is broadly applicable to much of the Rocky Mountains and really to mountainous snow-dominated systems worldwide. The watershed we work in, as Dan alluded to, is a roughly 300 square kilometer experimental watershed that encompasses strong gradients. Again, it's near the town of Crested Butte, Colorado, and currently hosts the research activities of over 150 investigators. It's become a wildly successful project, particularly given it was only stood up with the first stream measurements being made in 2014. The watershed itself comprised of 4 principal drainages going from left to right. Those are Coal Creek, Slate River, Washington Gulch, and the main stem of the East River. What you heard primarily from the Sail and Splash campaigns is an outsized focus on the main stem East River, but we do have experimental activities and data gathering that are critically important to the overall objectives of Sail and Splash in these other important drainages. And so I want to give you a sense of really what does this system diversity look like in terms of what I refer to as this diversity of eco gradients. And so from upper left going in clockwise fashion, we have very strong gradients in vegetation and vegetation composition. Those really demarcate themselves along gradients in elevation and gradients in climate. Additionally, particularly as concerns bedrock processes and groundwater system behavior, we have really strong gradients in the geologic composition of bedrock. Additionally, within these different reaches of the stream systems within these 4 drainages, we have really strong gradients in fluvial processes, particularly in the energetics of fluvial processes, from very high energy, very steep gradient systems to more graded channelized medium energy systems to these lower energy meandering components of the river system that really promote a variety of hyporheic exchange processes, so surface water, groundwater interactions. And lastly, due to the presence of naturally mineralized rock in historic mining activities, there are strong gradients in metal loading throughout the system as well. So really a diverse system. And so how does a group such as ourselves tackle so much system diversity? We do it through the creation of, again, what I refer to as a community watershed. We're all a part of this, and we're working to accomplish collectively what couldn't be accomplished alone by a single institution or a single federal agency. I think that's really, really important. And so again, this community watershed is a multi-institutional, multidisciplinary team. It's led by Berkeley Lab, and its key partner and site host, the Rocky Mountain Biological Lab, or Rumble. You've heard quite a bit about them. They're really key partners and serve as a research aggregator and really a broker to stakeholders within the watershed. And so by maintaining this important community watershed approach, we afford tight coordination of research to promote collaborative, i.e. open, rather than duplicative or closed science. We really try and avoid stovepiping and really, researchers working in a very independent and non-integrated fashion. That doesn't help us collectively. We currently involve the research activities of 7 different national laboratories, 20 universities, 6 federal and state agencies, 3 local stakeholder groups, and 6 small businesses through DOE's SBIR program. Some of you may be familiar with that program. The watershed, again, as far as broader outreach and relationships are concerned, currently hosts 2 newly awarded National Science Foundation Critical Zone Collaborative Network projects. One of the important ones, well, they're both important, but one of the ones that's more local, some of you may know Holly Bernard from CU Boulder. She leads a really critical zone project that's now based within this watershed. The USGS, as part of their next generation water observing system, has a strong footprint here, working in coordination with us as well. And as Allison alluded to, we believe we've heard positively on 2 to be awarded. Those are still TBD DOE ASR projects. Again, to date, 150 investigators, staff, students, and postdocs with a disciplinary focus that is, as you can see, pretty extreme, from hydrology to atmospheric and cryospheric sciences. And so it's important, an important part of the community watershed is what I refer to as a give to get model. We, Berkeley Lab as a lead institution, really tries to collect, install, and maintain data and scientific resources that are broadly applicable. What do those include? Well, they include a network of MET stations and flux towers. That's actually Dave Duchess climbing one of those towers that we referred to before. We have remote sensing data products. We've worked closely with NASA and now what's referred to as Airborne Snow Observatories Incorporated to collect multi-year, multi-season remote sensing data that relates to distributions of snowpack and snow water equivalent at the scale of the watershed. We have higher resolution remote sensing data products for those that are interested in really getting high resolution sub 1 meter digital elevation models. We have an extensive stream gauging network to, again, try our best to link precipitation patterns and precipitation distribution with variations in stream flow. Tilden alluded to the importance of trying to collect hyperspectral data. Well, we have a 300 square kilometer hyperspectral data set for the entire watershed that was collected in 2018 by the NEON program as a part of their airborne observation platform. Again, this linkage to bedrock processes and groundwater. We have an extensive network of groundwater wells. We handle the drilling and coring operations, and importantly, not just for drilling, but for a lot of the activities taking place with sail and splash, permitting issues as pertain to NEPA requirements in the U.S. Forest Service. Again, we work very closely with the Rocky Mountain Biological Lab to help us install this much larger network of research infrastructure. RMDL provides an important space for laboratory studies, high-speed internet, storage space for our sort of community use of off-highway vehicles and snow machines during the wintertime. We currently have a network of 11 weather stations, 1 eddy covariance flux tower that Dave Duchess alluded to, the 2 snowtail sites, and the 1 EPA CastNet station. And we have an extensive groundwater monitoring well network that interrogate depths from anywhere from 1 meter to over 100 meters in depths. And I alluded to before the stream gauging network between those from the Watershed SFA and the USGS, we have 15 different gauging sites of relevance. And so I'll finish this. Again, this is not meant to be prescriptive at all, but just some of these research questions that I'm super excited about being able to leverage these activities of the Watershed SFA and Sail and Splash. So in turn, how do spatial variations in precipitation and phase, snow versus rain, impact soil moisture and stream discharge? How does summer and fall monsoon impact antecedent soil moisture conditions in the following season stream flow? How does complex topography control snowpack accumulation, sublimation, snow melt, and groundwater recharge? That's critically important. How does spatial temporal variations in aerosol deposition impact snowmelt rates, snowmelt patterns, nutrient delivery, and hotspots of subsurface microbial activity? And can we quantitatively track the input and impacts of cloud seeding? weather modification in this valley and in Colorado more broadly is actually really important. Can we actually provide insights into the input impacts of cloud seeding at the scale of a single 300 square kilometer watershed? And lastly, I think this is really the sort of the critical take home of the interaction of these various teams of researchers, is really getting at what is the minimum but sufficient amount of information spanning that atmosphere to bedrock continuum that's needed to accurately predict flows of water and solutes from the system, not just now, but as we move forward, facing changes in climate and increasing occurrence of weather extremes. So that's all I have. Thank you very much, and welcome to our new community of watershed researchers.
Great. Thanks, Ken, so much. Yeah, I think it's a really exciting opportunity, and I hope that that we can think about this minimum but sufficient question throughout this breakout and onwards. So I see that we're a few minutes behind, but I think we still would like to hear from a new project and something that's really neat and kind of cross-disciplinary. So I was hoping to hear from Haruko Wainwright and Scott Collis regarding connections between the research in this and the AI for our system processes, and introduce those who may not be familiar with this to the attendees. So Haruko and Scott, I'll cede the floor to you.
That looks good, Haruko. We can see your slides just great. Thank you, Haruko.
Great. Thank you. Thank you for having me here. So my name is Haruko Wainwright. I'm the core team of this AI for ESP effort. Nikki Hickman and Scott Collis are in our ASR group. Scott is the co-PI of SAIL project, and Forrest Hoffman is a scientist working on carbon cycle. So these four of us are sort of the core team leading this initiative in BR EESSD division. So AI for ESP, we want, this is sort of the vision and initiative to sort of accelerate the use of machine learning for our system predictability. So this initiative started late last year. So the vision is that we want to develop framework to combine current DOE's experiment observation facilities like ARM or SAIL and E3SM or simulation capabilities, so that we can improve the predictability of Earth systems. We can quantify and reduce the uncertainty, particularly eyeing on high resolution models that we have, hydrology or carbon cycling or atmospheric processes. So in this initiative, we want to define the paradigm shift, how we can use artificial intelligence, machine learning across field, lab modeling capability and activities. And we want to identify what is the activities that needed to make a advancement, disruptive advancement for this domain in the EESSD program. So in our BR programs, we call MODEX, sort of model data experiment enterprise. So we try to accelerate the cycle of data to model and the feedback from the model to the data acquisition. And we do have a lot of computing resources like supercomputers, how we can use these computing resources, and how we can use all the data facilities like ARM and Amerifrax and so on. So we are talking about how we can use AI and machine learning at every aspect in this MODEX wheel. So you can see that how model simulation could guide or could provide knowledge, improve knowledge about the ecosystem or our systems. And this can feed into sort of new experiment, new measurement, and then machine learning can be used to, of course, data synthesis and discovery, hypothesis building, and model development, and then come back to the simulations. So, for example, we talk about how we can use machine learning AI to guide experiment sampling design. We are very interested in edge computing, 5G, sort of the more data stream from the field to the computing resources, how we can use pattern recognition, discovery, accelerate the discovery, and also sort of hybrid machine learning, physics coupled or system models. So far we had white paper calls last year. I think many of you have submitted white papers to this call. The focus topic is extreme water cycle. We know that there are so many topics within our division, but we sort of, to make it more manageable, we put the focus on extreme water cycle. And we had 3 focal areas: data acquisition, assimilation. The second one is predictive modeling, the use of AI, physics coupled AI, for example. And the third one is sort of pattern recognition, getting insight from the complex data. And we are hoping that these 3 focal areas are cross-cutting across hydrology, ecosystem, carbon cycling science, and then atmospheric science. So that's sort of the vision, that we try to focus on sort of the AI techniques part, hoping that that would be more cross-cutting, so that if there is a AI techniques that are used in ASR domain, for example, that can be transferred to TS or SBR domain, so that we can sort of enhance the use of machine learning AI across divisions. So that's sort of the goal. And we have 155 white papers, and now we have a website. Those white papers are publicly available. You can go to this website, ai4esp.org, and you can see all the white papers. There are great ideas, and you might have better ideas. Please let us know. One thing, we did some machine learning of these white papers. We can do machine learning of the document. So we had 155 papers and sort of did machine learning of all the words, how often these words come up, for example. So these are sort of the bigger circle mean that more like often show up across all the white papers, so that you can see sort of machine learning AI, of course, those are most frequent word. You can see atmosphere, flooding, cloud. In this domain, I think you might be interested in aerosol, for example. So these are the words that came up. And in terms of machine learning and AI methods, LSTM, deep learning, for example, these words came up. So I applied clustering approach. So we can actually cluster 155 papers to different groups. So these are the results. So it's kind of interesting that we see one group of people who talk a lot about atmosphere, aerosol, cloud. And we've noticed that the ARM ASR people have own papers. And then there is another group focused on sort of like soil moisture, carbon cycling, sort of extreme water cycle on ecosystem. We see like FATE. This is the plant community simulator in E3SM, our system models. So and then sort of that middle part is something else. So we kind of see sort of that separate clusters, more like ecosystem people and ASR people. So those are the kind of observations from the white papers. And from this, I think that this community, SAIL, Splash with SFA and other collaboration projects are very important to connect these sort of cluster 1 and cluster 3. What is the impact of atmospheric processes on hydrology, ecosystem, and downstream water resources. So in terms of the path forward, here is sort of the timeline. Again, all the white papers are available at our website, ai4esp.org. We are expecting to have a workshop on this topic in October. We will organize the workshop based on these 3 focal areas that I mentioned, and we will have separate breakout sessions, again, sort of the cross-cut across atmosphere, ecosystem, hydrology, and sort of all the EESSD domain science cross-cut focal areas. But also, we also identify that some of like AI in hydrology, sort of siloed, is actually pretty important to go deeper into each domain science. So we are trying to have sort of cross-cut and silo breakout sessions and identify what are the AI and machine learning opportunities and needs in each domain science, but across the domain science. So I think that the needs or opportunities from this data set from SAIL, Splash would be very important, not just siloed sort of particular domain science of atmospheric, but it would be very advantageous, or it provides great opportunities for machine learning and AI across the EESSD, combined with streamflow and ecosystem datasets that Ken mentioned. And we will have workshop report probably later this year, and that will define the new direction of machine learning AI in this program. And hopefully we'll have projects coming up on this machine learning and AI topic. I just want to mention one thing. I lead the watershed characterization in SFA that Ken mentioned. So we have this machine learning guided monitoring network we are putting up this year. So we have snow temperature, sort of discrete temperature probes, so that we can measure snow thickness, but also the snow temperature discrete, and also small sort of very local sensors of rain gauge, soil and air temperature monitoring posts across 120 locations. And we decided these locations based on the machine learning to capture sort of the covariability among snow, topography, and plant drought sensitivity. So we are hoping also to connect this cluster 1 ASR group data set, and also that sort of the ecosystem hydrology side clusters. So if you're interested, please let me know. And yeah, I'm happy to contribute to this group. Thank you. Scott, do you have any additional?
That was fantastic, Haruka. Maybe the only thing I really point out, really double down on what you said, but also what Ken said, which is one of the reasons why SAIL is particularly interesting to AI for ESP is because it is an ARM-supported, ASR-aligned deployment in a watershed SFA. So it really does touch on many parts of the ESSD directorate. So it's very much viewed by the core team and the program managers involved as kind of being an all-encompassing thing that we can target there. And frankly, and this is what, us core members have been learning a lot from our colleagues from OSCA about the use of AI, because of the non-linearities involved, the interfaces involved, and the discreteness of some of the science we're looking at. Some of the science questions we're aiming to tackle within SAIL are very well appropriate for AI, and we've seen that from a lot of the white papers. And we want to thank you all for your patience, by the way. This has been a very moving target, AI for ESP, so I know a lot of people who have submitted white papers kind of feel like they've been left out in the cold. This has not been our attention, and actually this is a really good thing, because there is increased intent and increased attention on AI for ESP, and that has been one of the things that has delayed us a little bit.
Thanks. Yeah, so I guess yeah, there's a large number of topics that we've touched on, and I wanted to thank all of the speakers who have taken their time to present here. I know we're a few minutes, we've slipped our schedule a little bit, but we do really, I think the discussion has been really active in the chat. It looks like there might be some
Yeah, Dan, we've actually got some specific questions in the chat. You know, Ranjit has a question for you. Can you please repost the email address for folks to get involved into the chat?
Yes, I will do that right now. And so there's a couple of different there's a mailing list for the Sail and Splash bi-weekly teleconference, which I think is the best way to kind of keep up with what the campaign is looking like. There's a little bit of a danger that if you join, that you might be asked to present. Voluntelling is a thing that I do. So, but yes, please join that. I'll send that right now.
And there's a question here from Aaron Kennedy aimed at Rob and Chandra. With the side lobes, how close to the ground do you think we're going to get with the radar systems to get useful data?
Hey, Scott, I answered that
on
the chat itself, but I will repeat the answer. So we have fairly good clutter suppression technique, but some scientists don't like to suppress clutter because they want to see the clutter. So I should say 0.5 degree to 1 degree, we should do quite well related to the surface. And but I've been studying clutter for 30 years. For everything I say, there is an exception. And for every exception, there is a solution. So not an issue. I can work with specifics on whoever is interested.
Great, thank you, Chandra. And there was a long conversation between Ola and some others in the chat, and a lot of that is actually spilled over to Slack. So I strongly recommend folks to go over there and follow that. And I will actually try and do a cut and paste from the chat before we finish. But I do believe that ORISE gets a copy of that. There's a question here from Gijs to Allison, if Allison's still online, saying this would be great. At the moment, we're probably not here. Sorry, actually that's an answer to Allison, but I know Allison and Gijs, if you want to unmute and cover the UAS question there.
Yeah, sure, Scott. I was just connecting with Allison about she had a list of different potential additional measurements on the aerosol side, and I mentioned that we're trying to find support to get the UAS systems that we have set up for Tracer with POPs on board into the field for Splash as well, so that we can collect profiles of size distribution for the particles. But that's still in progress, and I thought I would let her know that we're doing our best to get there. And then there was a little bit of follow-up as well. I know Fred mentioned that he's got a bunch of interesting instrumentation, Fred Brechtel, that could be UAS ready. There was a few questions about whether things like mini CCN or other sensors might also be in the mix. And my response was not on the platforms that we're currently thinking about, but if there are opportunities for larger platforms, I'll certainly keep all of that in mind, and I would love to see it.
Gijs, it makes me think, and looking again at Dan, we've got a couple of really active, nice subgroups within SAIL. Maybe an airborne, which would be a mixture of the tethered SON and UAS subgroup, might be a good idea. There's also a question here from Alexander Laskin aimed at Allison. Allison, are there any short-term aerosol IOPs planned for SAIL?
So not currently right now. We, Jim and I surveyed the Aerosol Processes working group, and there's a lot of interest. And so I think we're going to need to follow up. We can start discussing this and continuing it on the Slack, and having more information available to people to figure out when is best to try to coordinate an overall aerosol focused IOP.
Awesome. And I think most of the other questions have been kind of answered in conversation in Slack. So Dan, I think we're good for open discussion now.
Great. Thanks, Scott. And I really appreciate again all of the interest here, the attendees sticking with us, and really want to open this up to any questions you have. I have some discussion seating topics, but if there are points that have been on your mind throughout this discussion, throughout the presentations, would like to open those up. Feel free to raise your hand, and we can get that process started. I recognize that the Zoom format is still something, at least that I'm kind of warming up to, and with these large Zoom meetings. So I'm happy to sort of push this forward, but don't want to overly color it. So please, if you would like to raise your hand.
And I'll keep track and count of hands raised and cue them appropriately.
That's good. And then I guess while we're waiting for that, since time is limited, I saw that during the right at the end of the AI for ESP discussion, that Jeff turned on his camera. I'm not sure if that was to chime in or just to say hi. But regardless, Jeff, if you wanted to give your perspectives here, we'd certainly be highly appreciative of that.
The only thing I was going to say is that AI for ESP is not an exclusive club, that these are a bunch of people that submitted ideas, and we are going to cast a big tent. And so these are people who are excited about it and are interested in collaborating with other people. So if you think that AI or ML could perform a useful role and you don't have somebody to work with, you're the perfect person to come to some of these workshops. So it was more of a pitch for recruiting. Scott, you might want to build on that. I saw some nods over there.
I completely agree with you, Jeff. We actually have a Slack workspace that everybody is welcome to join. If you actually go to the AI for ESP.org website, there's a contact us link to get access to that. To kind of go back on what Jeff said, expect to see the scope be larger than the original AI for ESP white papers that were submitted. That is very, very clear to us now. And again, folks know the changes that have occurred over the last 6 to 7 months within DOE, so keep an eye on that as well. But folks might wonder, looking at Haruko's talk and what Jeff and folk said, what is the actual outcome going to be from AI for ESP? And it's been made very clear to us by DOE and Gary and team that they expect to see a variety of activities funded in longer term across existing programs, but it really will be that workshop report. And anyone who's worked with DOE knows that we need these workshop reports to act as a document of record of what the community wants and what the community thinks that DOE can be, that is linchpin and science changing. And that is what folks like Gary will use to build new programs within DOE. So this is, if you've ever looked at a program and gone, damn, why wasn't I in on the ground floor? This is still your opportunity to be in on that ground floor. So
I'd like to
Yeah, this is Nikki. I'd like to reiterate that, yes, the ground floor really is going to start when that workshop comes out, workshop report comes out, and it has expanded to include Oscar. Since we put things out, it has expanded in changes in wording from the administration and what we're hearing from, other areas of the government. So I think the, those changes we do expect to incorporate for the workshop, and we're hopeful that a lot of the collaborations that came out from other people reading each other's white papers, that those will be built on prior to and throughout the workshop. So please keep forging ahead, and we're trying to scramble to make sure that we have all those changes and we're ready to go for this workshop so that we can include them in the report. But we're looking forward to having what you put in the white papers, but more importantly, what you've advanced with each other since. So thank you everybody for providing all of that.
And Dan, we have Jim Smith's got his hand up there.
Yeah, thanks. So I guess there's been some questions in Slack about this, and this has come up a few times. So I thought maybe we could make this kind of open. Is there any hope at all that the campaign can be extended into the summer to allow people that are participating in Tracer next in 2022 to have a campaign, or is that just a non-starter?
This campaign's already going 2 winters and 1 summer, so it's pretty much a non-starter.
Okay,
thanks. I mean, minor adjustments maybe, but not major.
Ice.
Yeah, I'm somewhat connected to the earlier discussion on the AI ML stuff. I'm really interested in the probes that Haruko showed in her presentation, and it'd be great to get some additional details on kind of the status of those, whether they're already deployed, when, or if not, when they're going to be deployed, and get some additional detail. Maybe I missed this in the presentation, but what the ML components are there, and what exactly, how that fits in. But it's certainly something that has the potential to provide information on topics that we've been discussing a lot, which are getting additional detail on kind of distribution of snow depth, for example, and snow temperature on the slopes and away from the main valley. So Haruko, would you be willing to share some additional information on those here?
Yes, so those sensors will be deployed in September. And in terms of the locations, there are sort of distributed across the different elevation, gradient. I believe that the maximum snow depth that it can measure is, I think it's like a 2 meter, unless you put like 2 sensors kind of stitched together. So there is some upper bounds, so that upper super high elevation, the snow depth goes beyond 2 meters. So that's sort of the limitation, but we will deploy this September, and I'll send you the more detailed spec and information.
Okay, thank you very much.
It's very cheap. It's less than $100. Yeah.
Haruko, can I encourage you as well, if you have any details you're sharing, to throw them up on the Slack workspace that we have. I don't know if you have access to the ORISE Slack workspace that's been set up, or put them in the chat and I'll transfer them through as well.
Sure, thank you.
Ola was next up.
Yeah, this is kind of like a question for Gijs and Splash in general. I believe you said that you're just planning to do this from September to, was it April of 2022? Why not continue it through the summer melt season, so we know better how much of the runoff during the summer and late spring are due to the melt of the snowpack versus contributions from rainfall that occurs in late spring and summer?
I think you maybe misunderstood the timeline. It is going through the summer, probably until August of 2022.
Okay, all right, thank you. Yep, sorry.
That makes everyone happy. Fred was next. And you may be muted, Fred. You might need to hit your mute button. There we go.
All right. So I'm brand new to this group, but I really appreciate some of the summary talks that were given. One thing that struck me was the complex terrain and the complex transport patterns are going to make it very, very difficult to interpret some of the results. I spent quite a bit of time up on Niwot Ridge trying to sample aerosols and was consistently dumbfounded by some of the things I saw. So I'm a little bit surprised there isn't a stronger in situ airborne measurement component. And I'm perhaps the remote sensing activities are meant to, you know, kind of fill that. But even with the remote sensing, I don't know that much about the remote sensing side of things. So often interpretation of aerosol measurements on the ground can be pretty tough. I'm not sure how much information from the remote sensing, the radars, for example, are going to be able to help with that, and whether they're, you know, whether those kinds of voids are going to get filled.
Yeah. So I'll provide some perspectives on that. I think I really appreciate the question. It's extremely well taken, and you know, complex terrain is marked by first order heterogeneity in processes, in observables, and the interpretation to really advance the scientific understanding is something that we need to demonstrate through these campaigns. And so that's something that is not something to be you know, sort of asserted in any sort of way. We have some remote sensing capabilities. The scanning radars that Chandra mentioned. We have are fortunate enough to have a really nice scanning LiDAR capability that has a nearly 10-kilometer range, and have stood up a scan strategy for that. And I think you know, sort of the network of observations, we're really going to be working with very closely with the you know, with the network of observations that are already present from the Watershed Function SFA, the combined measurements from sail and splash, and hopefully in training community measurements as well, to really try to address this as much as we can. There are you know, logistics issues in terms of accessing some of these locations at certain times of year. Power and safety are things that have really been first and foremost, safety first, and then power and other sort of logistics after that. But as we sort of seek to characterize in a way that is sufficient, that the types of heterogeneity in precipitation, aerosol, surface flux, and just the things that impact mountainous hydrology, we're seeking to advance that as much as possible. I'm hoping, but this is an extremely important point, because it is also allows us, or is a, you know, in terms of learning and extending what we observe and learn to other watersheds in the upper Colorado River, even just the watershed next door, is an important point. Yeah, maybe we could, if I don't want to put people too much on the spot, but maybe would like to hear from Ken and Gijs and I guess a number of the presenters on kind of their perspectives on that.
Dan, I want to also put a request to Gijs to also ask what he thinks the role of using something like HER or Rufus or other modeling backgrounds, you know, maybe even a, you know, nesting an LES model in that, how that might help really characterize flows through the valley.
Yeah, Scott, I think it's a good point. I don't think we have an operational plan to do that right now. I mean, particularly at an LES type of thing, but I think we could use the high resolution simulations to support understanding of specific events and cases. I also think, Fred mentioned potential airborne measurements. I do think that there is an opportunity there, but it's also challenging given the duration of sail in particular, but also splash. We're talking 1 to 2 years. It's really difficult to support over 1 to 2 years airborne observations of any kind just because of the cost involved. And so I think those would always be kind of targeted at specific times of year, whether it's, aerosol for summertime convection, for example, or for winter storms. We might be able to think about whether there's an IOP type of opportunity there that could be pursued. And at the same time, this is all starting in a few weeks or months here. So the timelines are not huge for trying to spin that up. I guess that's my quick feedback, but I do really appreciate your point about our ability and opportunity to use the modeling tools. I think there is a good chance there to better understand some of the transport involved. And again, the remote sensors, like Dan mentioned, to understand some of the local wind patterns. And it was also part of the design of Splash, to be honest, to get a little bit more spatial coverage throughout the length of the valley and not just have the single point, but get kind of a line of surface measurements to understand how the flow is kind of working its way through the valley there.
I see Rob Newsom is on here as well, Dan. One thing I'd say is that we need to, the science team at least, needs to communicate to Rob about, the operational mode of that scanning Doppler LiDAR, because I know at the moment they often will point it vertically for quite some time and occasionally do a scan. So we want to think about that.
Yep. And yeah, Rob, I don't know if you wanted to if you're able to unmute and speak to kind of the scanning strategy that we're thinking about for that instrument.
Well, the scanning strategy so far has been discussed between you and I. And so, my plan was to be at the site next month to set up those scans, program those scans. So, right now I don't have anything specific in mind, but I'm going to be relying heavily on input from you guys.
All right.
Yeah, and I guess that's a point that for those who are interested, please follow up with within the Slack or with me or I don't want to put you on the spot, Scott, but certainly it's something that we're thinking about. There are the scanning instruments are programmable, and that we can that there have been discussions about kind of ongoing scan strategies, things that we sort of day in, day out are configuring the observations of these instruments. They typically have a lot of vertical measurements as vertical staring as for the Doppler LiDAR, as Scott mentioned. They do have the ability to do PPI scans and sector and RHI scans, and so I think there's a lot of opportunities there, and also opportunities to propose limited a limited sort of research scans. Yeah. So and that also. Don't want to put Chandra and Rob on the spot too much, but that goes for the scanning radars as well. That there are some opportunities, and this is where I think thinking about standing up hypotheses to test provides a really with scans and with the kind of the network of different observations that we have to really figure out if we're if we're really achieving the minimum but sufficient condition that Ken mentioned here, that or at least that's a guiding something that guides my thinking here.
And Ola's had his hand up for a little while there.
Yeah, I actually had several questions. The one about the aircraft flights was already asked, so I'll skip that one. I agree. I think some aircraft IOP opportunities really should be taken for this field program. But I was wondering a little bit from the locations of the Doppler radar, scanning radars, is there any opportunities for dual Doppler analysis, especially the airflow in the complex terrain there? What I suspect is going to happen, or you'll see, is that for these snowfall events, that the airflow below mountaintop height, so within the various valleys and the side valleys, you're going to have quite a different flow regime than you will have up above. And defining the depths of those different regimes and the characteristics is going to be really important. And so one, will you be able to do some dual Doppler analysis to separate out those kind of airflow regimes? And secondly, will there be soundings to get the thermodynamic vertical structure?
I mean, Chandra, you can answer that briefly, but I've got a little warning that's come up on my screen saying they're going to kick us out in 50 seconds. So
okay, there are songs, and we can do some Doppler, dual Doppler likely, but we'll follow up in case we do get kicked out.
But Daniel, you want to also advertise a workshop coming up, don't you? We can't forget about that.
Yeah. So stay tuned. We're going to be having, right around the start of the campaign. We're going to be trying to reach out to as many of you as we can to really have some more detailed discussions.
Hey, Dan, can I add 5 seconds on the dual Doppler?
Yes, please.
Well, the short answer is yes, and that's what I tried to allude to in my slides, and I can add more information to somebody who's interested. And enabling the dual Doppler was one of the main things I was talking about.
If they probably were finished in their session and get it for everybody.
Deep convection was definitely still ongoing.
Hey, we're back.
Okay. Well, sorry about that. For those of you who are still here. Okay, so maybe we could talk about if Chandra and Rob are still on about dual Doppler.
I think they're still putting us back in the rooms here.
Okay.
Yeah, I see both of them on the participant list, so hopefully they're there. Chandra and Rob, are you back?
While we wait for them to speak up, Dan, I want to add another thing.
Can you hear me?
Yeah, we can hear you, Chandra. Excellent.
So the main thing is the short answer is yes. And then the long answer is in order to do dual Doppler, obviously, we need to have some sort of coordination between sail and the splash radars that we need to work out. And when I say coordination, I mean not pre-planning, but electronic coordination. That is, you don't want one radar looking east and the other radar looking west. We need them looking in the same direction. And we know how to do that, but like everything else, these are different funding agencies and different projects, and the priorities have to be worked out from the powers much higher than me. Technically, it can be done.
That would be great, and hopefully it will be done, because I think that'll be very important, as other people have chimed in as well.
And that's one of the main features, for lack of a better term, we made sure that happens. That is, we don't have blockage that prevents it from happening. And then, but this is actually, for me, a dream come true. Like I said, some 15 years ago, I wrote this into a National Academy report that this is the way to observe in complex terrain. And it's taken this too long to make it happen.
Yeah, it would be very interesting to see how much of the area actually could be covered with dual Doppler, because in complex terrain, you not only have the angles you have to worry about, but also the terrain blockage, as you say. So, and really limit the area that could be covered.
Oh, I'd also like to really, Chandra knows this as well, of course, is to like look at it, not just using 2 radars, what other constraints you could bring into this. This is going to be a really interesting data set, and there's going to be a lot of algorithm development done on it simply because of the complex terrain. A lot of the simpler methods we use for doing multi-Doppler will completely fail because of the assumptions we make.
Totally. That's why I was focusing on the vertical coplane.
Yeah, I like that idea, Chandra.
And long time ago, this technique was actually investigated very heavily for airports by Lincoln Lab and me. But again, these are very specific airport targeted applications, but it's coming to science from aerospace.
That's great. I think that will need to be an IOP mode that we enter into, and kind of again thinking about how we could use some other sensors in that, such as the scanning Doppler LiDARs for clear air, but also then using model like her as a background or something like that.
Mm-hmm.
Dan, one point I want to raise, listening to the amazing stuff from Splash, especially the snowpack flights, is that we're going to have some data sets that are going to span multiple agencies, even multiple areas within the same agency. And I think that we need to have a really careful look at how we advertise the existence of all these data sets so that when folks are doing sales science, they're not disadvantaged because they don't know ways of getting something. And I want to specifically ask Ken, you mentioned a whole bunch of anemometers and MET stations at Rumble. How does Rumble and the Watershed SFA make that data available? Do you have a clearinghouse? If Ken is still here, which he might not.
I can chime in a little bit.
Yep.
So there is a data portal for those. There's a very serious effort through something called ESS Dive
Cool.
that has been stood up. But data integration is an important point here, and I'm glad that you raised it, Scott. It would be unfortunate if researchers here within this breakout session, within ASR and ARM, and the larger scientific community with multiple, that span multiple disciplines, have to travel hither and yon to download, find understand the existence of data. So I think there are some ways that data integration can be advanced through simple things like tagging and some procedures, but also not to put too much of a bow on things, but this is where there could be some value, significant value for thinking about how AI methods could provide some glue across these or bridges across these data sets. So yeah, this is something that's ongoing. Please let's talk about that in the Slack though, since we only have a couple of minutes, or over email, or yeah.
Jerome does have his hand up just there.
Yeah, I just had a clarification on the scanning LiDAR, if Rob couldn't chime in. We just had a campaign deploying 2 scanning LiDARs in terrain, in a valley. So we tried to do the dual Doppler scanning for that. In the end, it didn't work, but that was primarily because of where we could site the LiDARs in order to have good overlap. So my suggestion is, if you want to have that sort of thing that involves some planning ahead of time to do it, and it all depends on the range, the scanning LiDARs, and that they can actually overlap. And that will probably depend on the season and how much aerosols are around. Other than that, you can get some really good radar velocities of the flows, low-level flows in the valley.
Very cool.
Yeah, and the other thing I should point out maybe is that we will only have a single Doppler LiDAR. I'm not aware of any studies in the past of people trying to do dual Doppler between a LiDAR and a radar.
Oh, Rob.
But that's an idea.
Yeah, and also lots of people have done single Doppler radar and nudging model fields with some success to kind of get that fine scale, cloud scale flow as well. And that, again, I kind of look at something like using a HER background as your initial constraint and then using a mixture of radar and lidar there as well to nudge that to something that's more representative of the flow through the watershed there.
Thanks.
Yeah, just quickly, we will for a very short amount of time have a second Doppler LiDAR, but that's only for this coming fall with the clamps trailer that will be deployed.
Well, we should really highlight that time period, Gijs, as a possible kind of
Absolutely.
as an IOP kind of period.
Yes, indeed. I wasn't aware of that.
Okay, great.
That's why we have breakouts.
Yep. So we have okay. So let's we are at the 2-hour mark. So I did want to thank everyone and really appreciate the time you've taken, all of the presenters, the discussion, and I hope that this is really an opportunity to really just start conversations or continue conversations moving forward. And so I think that Slack is a really fantastic way to do this. But other methods, feel free to reach out to me or to others who are interested in discussing. And so again, thank you, and I hope to see you virtually or hopefully at we have submitted a town hall for Sail and Splash to the AGU. So if that's either virtually or in person, you can see First Light there. And go September 1, go to Armed Data Discovery, start downloading. Yeah. And the Gijs, there'll be some data sets through the Slash website available through that portal. Gijs, would you want to speak to those briefly?
Yeah, we're not much to say about that right now. As you know, we're in active discussions about the data, both internally within Splash and then connecting with the DOE group. So I think the best thing I can say is stay tuned, look for it. We'll be sure to advertise high and wide when those data are available.
Okay, great.
Very cool.
Okay, so we got some directions that to go get lunch or whatever break, depending on what time zone you're on, and we'll see you all at throughout this this meeting continuing, and hope to hear from you soon.
Thank you, Dan.
Thank you all.
Thanks, Dan. Thanks, everybody.